Welcome back to lab. Today we will talk about vectors of vectors and structs. But first, we're going to start with a debugging activity. Please go to the Google Drive and find encrypted.cpp, encrypted.txt, and encryptedkeys.txt in today's lab folder. Here we have implemented a program in encrypted.cpp that will decrypt the text in encrypted.txt. But there are 6 bugs inside of the code right now. So your job is to find those bugs and correct them. A hint to help you get started is to use G++ to compile the code and look at the compilation errors. So I encourage you to pause the video here and we'll reveal the answers once you come back. The solution is now shown on the screen. We have listed all 6 bugs in the CPP file and then the decrypted message. If you have any questions about these bugs, as always, feel free to ask us on Piazza or during office hours. Next up, I want to talk about vectors of vectors. But first, let's very briefly recap what are vectors. A C++ vector is just like a row vector in MATLAB, and they can only store one type of data. So in the code example shown on the screen, we first declared a vector, and then we added elements into this vector using the pushback function, and then we used the .add function to access the elements inside of this vector. If this is unfamiliar to you, please go back to Lab 10 and review the topics we covered last week. To initialize the vector, we can also pass in the size and the initial value to our vector. So in the example shown on the screen, we initialize our vector with 5 elements, and each of those elements have the value of -1. Vectors of vectors is just like a regular vector. Here, each element itself is a vector. To help you visualize this, on the right-hand side of the screen, I have drawn a vector of vectors. So here at each element in our outer vector, there is another vector that nests inside of it. We can think of our outer vector to be rows, and we can think of the inner vector to be columns within one row. To declare a vector of vectors, we can put the type vector of integers inside of the angle bracket of our outer vector. So notice here we have a space between the two closing angle brackets, and that's because if we don't put a space here, it looks exactly like an extraction operator, and some of the older compilers actually cannot tell them apart and will throw a compilation error. By putting a space here, we're being explicit here in telling the compiler these two angle brackets don't belong together. To create a vector of vectors, we can use a very similar syntax. We can use the pushback function, but here we need to push back vectors. So in the example shown on the screen, we first declared an empty vector of integers, and then we created a vector of integers. Right? So here we're pushing back this vector of integers into our vector of vectors. Once we push back this vector, our vector of vectors will have one vector inside of it, so which means that we have one row in our vector of vectors, and inside of this first row there are 5 elements. So to access these dimensions of our vectors of vectors, we can use the size function. So if we do my2dvec.size, that will give us the number of rows in our vectors of vectors. And if we use my2dvec.add0.size, that will give us the number of columns at the first row. Another way to initialize a vector of vectors is to specify the number of rows in the row we want to initialize our matrix with when we are declaring our vectors of vectors. We need to make sure that row, the variable we're using to initialize our vector of vectors, matches the type that we specify. We can also use the vector constructor here in place of the variable row, so we don't have to create another variable. Again, we need to make sure that our types match here. Both of these ways are equivalent, and they both create a 2D vector with 5 rows and 10 columns. We can iterate through our vectors of vectors by using a nested for loop. Here, the outer for loop accesses each row in our matrix or 2D vector, and the inner for loop accesses the data within each row, the inner vector. So to recap, vectors of vectors are vectors containing vectors, and that will allow us to create a hierarchical structure. We can interpret the vectors of vectors to be 2D vectors or matrices. the outer vectors contains each row, and each of those rows are itself vectors that contains the data of that row. Each row must have the same data type, but they don't have to have the same size. To use vectors of vectors, we need to use multiple indexing operators to access value at various levels, and we need to use multiple loops to access every element. And very likely, a vector of vector is passed by constant reference. Next up is structs. Remember in Project 5, we associated every keyword with the word itself, which is a string, and the weight, which is a double. Now the question is there a way to group these data together? And the answer is yes. We can combine them together into one abstract structure of data. I want to show you how to create a struct by walking you through an example. Our struct declaration will always start with the word struct, followed by the name of the data type. So in this case, our type is called keyword. When we're declaring a type name, by convention, make sure to always capitalize the first letter. Following the type name, we can see the attributes surrounded in curly braces. A struct can have one or more attributes of various types. So here we have two attributes, word and weight. So word and weight are called member variables of the struct keyword. And finally, don't forget the semicolon when you're done declaring a struct. In this code snippet, we define the member variables of our struct keyword. Here is another example that will tell you a little bit more about working with structs. Here we declared a different struct house, and the house struct contains one member variable, address. Notice that this declaration is outside of the main function. It only tells us what to include in a house. Okay. Next up, in the main function, we first declared a house and we called it temp. Next up, in the main function, we declared a house, and this house has the variable name temp. Next, we set the address attribute in our temp house to be 17 Cherry Tree Lane. So notice here we're using the dot operator here to specify address, which is a member variable of house. We can create vectors of structs. We can simply do that by specifying the type of the struct inside of the angle bracket following vector. So next we created a vector of house with only one house in it, right? Notice that we push back temp into our vector of houses. And finally, we can also create vectors of houses. So in this case, we created a vector of house, and we call it neighborhood, and then we push back a vector of house in it. Remember here that street has to match the type vector of house. So our neighborhood here contains one house and neighborhood of 0 of 0. Next up, I will show you a coding demo where we read structs from a file. Here we have our data file. In points.txt, which is where our data is stored, we have a list of 6 points. Each point is specified by their x and y coordinates, and the x and y coordinate is separated by a space. Let's write a program together to reading every point from this file into a vector of points. Here we have a C++ file with all the scaffolding already included. So let's start by declaring the struct point. Okay. So we start with our keyword struct, and then the name of our struct is going to be point. We use our curly brace, and we'll use a semicolon at the end of the struct. So let's assume all of our coordinates will be integers. So we can simply use int x and y. So each struct point will have two member variables, x and y. First, let's create a file stream that will open our data. So here, I created a file stream that will open points.txt. As we mentioned in previous labs, we can use a while loop to reading every line in a file. So what we can do here is we can initialize a point outside of the while loop, And then in the loop condition, we can read in directly into our struct's member variable. So here we first create, let's first create a point. Temp is a point variable that's empty. Next, let's use while loop to reading every point that's stored in our file. So here we're reading directly into the member variables of our object. So since our goal is to create a vector of points, let's create that before our while loop as well. So here I created an empty point vector that will contain all of our points. While we're reading in every point in our file, we can go ahead and use pushback to add that into our vector. Once we have read in every point in the file, we can go ahead and close our file. One way to verify that we have read in all the points in is to use cout to print out the size of our vector. To recap, we first declared the point struct, right? We specified that there should be an x coordinate and a y coordinate. In our main function, we first open the points.txt file using an input stream. And then we created a vector of points. We also created a temporary variable to store the current point as we're reading in our file. For every line, we read directly into the member variable of the points using the input file string. And then for every point, we pushed it back. Once we have reached the end of the file, we close the file. And we're going to print out the length of the vector for a simple check. So let's go ahead and open our terminal and compile the code. Okay, compilation is successful. Let's go ahead and run it. Okay, so we printed out the length of vector to be 6, which is expected because we have 6 points in our input file. So that's it for the demo. Feel free to contact me using Piazza or during office hours if you have any questions about this demo. So that's all I wanted to cover today. Today we covered vectors of vectors and structs. To complete the lab assignment today, you need to submit 2 C++ files to Canvas, and they're due on April the 14th at 11:59 p.m. As always, you'll have a weekly review due this Sunday. Project file is due on the other grader on April 8th, so please don't forget about that. And next week, there won't be a lab assignment. We will be holding office hours during lab time for Project 6 questions. This is the last lab video for this semester. I hope you enjoy watching them, and I hope they're helpful. I wish you all the best.